This presentation is comprised of important segments of seminars presented by Industrial Steam. It's intended to provide information, both general and specific, about the product line.
Question is, which deaerator, okay? And part of that, or implied in that question, is what deaerator can I get him to specify that's going to give me the best opportunity of getting the job, okay? How can I lock it in? And we have an internal decision tree that we go through, and we've simplified it to make it easy. We have 5 deaerators. Here again, what's a customer's objective? Right out of the box, we're going to propose a spray flow 2 deaerator. Why? It will give the customer, without a doubt, the best value that he can get, okay? It'll give him ultimately the lowest cost that he can get on an installed and an operating basis.
The Spray Flow 2 atmosphere deaerator is a brand new unit, and it operates quite different from any standard deaerators, atmosphere deaerators have ever been in operation. And the reason for this is the 2 compartments in the deaerator have been divided by a partition. And the partition separates the deaerating section from the atmospheric vent. The first section, or the mixing section, has the vent on it, and this is where the steam flow control is controlled. What happens here is that the water comes into the first section, the temperature controller energizes the steam valve and says we have to have steam. And the steam will bring up the temperature in the first compartment up to approximately 210 degrees, at which temperature oxygen will start to leave the water. This is the first effect of this deaerator. The second effect of this deaerator is the second compartment, or the deaerating compartment. Steam enters the deaerating compartment and flows over the top of the spray nozzles that are spraying the water into that compartment, and the balance of the steam is then transferred through the downpipe into the heating scrubbing section of the first section. We have a deaerator here that is so far surpassed of any atmosphere deaerator that's ever been out or manufactured. And they say, why is this thing so unique? Well, I'm going to say this again and again. It's unique because it's double effect, and it absolutely controls the water temperature where it must be controlled, and that is in the mixing section, where it brings it up to the 210 degrees, 211 degrees, and which is our first effect of deaeration. If you drop this down to 208 and 109 degrees, you're not going to get that full first effect. The first effect comes from that point, bringing it up there, and then when it goes into the second section, you get up to roughly 213 degrees, and that's your final effect. And this is what makes it a good deaerator.
I want to show you how this thing works, because it's really very interesting. See, this actually turns the deaerating cycle backwards. Most people in a deaerator will deaerate and then scrub. They deaerate initially and then they scrub it. This does it the other way around. Scrubs first and deaerates. We have, those of you that were at the plant today saw the inside, saw the scrubbing section, which included it was not a perforated tube, it was a slotted tube, but it's pretty much the same idea. In one of them, there was 2 manifolds side by side, one higher than the other. One is for water and one is for steam. The steam one, of course, is higher than the water one. The water recycles through here into the bottom of this receiver. The steam is taken through into the same chamber through a separate pipe, parallel, and it mixes right here. Now, what really happens is that this steam is controlled from this end. And that's the secret. The steam going in here is controlled from over here. The new water, which is sprayed in here, very much like any of our deaerators, into a stainless steel vent condenser and falls into the scrubbing section, which we hold at about 205 to 208 degrees. Why? No flash loss. Secondly, when it's transmitted over here and sprayed through these little pigtail nozzles that you saw at the plant, and I passed around yesterday, these little nozzles, the water is 208 degrees. So this doesn't have a lot of heating to do, but boy, does it get the final deaeration done. Now, there is a slight positive pressure in here. And why? Because you got a back pressure here of water. You got to take the steam through here and pass it up through this water. And it's just like blowing water in through a straw down a glass. There's a back pressure equal to the head of the water.
When you have an atmosphere deaerator, you never get pressure decay. Maybe I should explain what pressure decay is. Pressure decay in an aerator means that the pressure, if you're operating at 5 pounds at 227 degree steam and 25 degree water, and the pressure drops in that aerator for some unknown reason, you get flashing. It's called pressure decay. And what this pressure decay does, it affects the feed pumps immediately, because the feed pumps are set up for a given NPSH, which is always lower than what the head of the water is in the receiver. And if it starts to flash in there, it's going to flash right into the eye of the impeller, and the pumps are going to flash. So this is a big advantage that atmosphere deaerators have, because it's impossible. It's that atmosphere. It can't go any lower. So they're not going to flash. And this is quite important. And I'll tell you the place where it becomes important. When you have a smaller operations and you have on and off boiler feed pumps, you many times go way over the capacity of the particular boiler feed pump. And we all know that pumps are designed to pump a certain head at a certain RPM and pump a certain volume. Whenever that volume goes more than what the pump should be doing, you're going to get flashing, particularly if you're pumping boiling water. And this will be true in the atmosphere as well as in the pressurized. But pressurized happens immediately. Atmosphere takes a little bit of time. It gives you a chance to level the thing out. So again, one of the most important things in the whole deaerating field is when you put pumps underneath them, and you're going to have on and off boiler feed pumps, be sure that the pumps are controlled to pump the volume that the boiler requires, and not 3 times the quality out of the boiler. Because if you do that, you're getting much too much water, and the piping isn't sized for it, and you're going to get boiling or flashing inside the suction line pump as well as coming from the deaerator. So what happens is when a pump flashes, it throws it out of balance. You have air on one side of the impeller and you have water on the other side of the impeller. It's going to sit there and it's going out of balance, and it'll start sounding like you're pumping marbles pretty quick. And you say, oh, wait a minute, what's happening? First thing that happens, seal goes cramped, bearings go out on the pump. And actually, when flashing takes place, it can eat into the bronze impeller like you took a hot knife and went it through butter. Comparing this atmosphere deaerator with a pressurized deaerator, we operate this deaerator at 210 degrees in the first section. The same as a pressurized deaerator would spray water in that first compartment and bring it almost up to corresponding pressure. In other words, a pressurized deaerator operating at 5 pounds, the steam temperature would be 227 degrees and the water temperature be 225 degrees. This lets you know that if you keep that water up to 210 to 211 degrees, you're doing approximately 80% of your deaeration at that point. So here's where the thing comes with the SprayFlow 2 deaerator, where you get absolutely double effect. That's the first effect of deaeration, and when you transfer it and spray it over the spray nozzles, there's your second effect. And that is important.
What does hot water do? Go up or go down? Goes up, doesn't it? So you have a natural thermal circulation here. This cold water hits here, and it wants to go to the bottom because it's heavier. And this water wants to go to the top because it's lighter. And so you get a thermal circulation within itself. It just does a beautiful job for maintaining the temperature because you have a steady flow of temperature.
I want to touch on the recycling part of the deaerator. We came up with the recycling on this deaerator about 22, 23 years ago. And I'm going to say it was one of two most important changes that have been in the deaerating field in the last 100 years. If you look at the unit at the scrubbing section, there's a transfer pump on the bottom of this section that pumps the water into the deaerating section where it is sprayed in a real fine spray, and at the same time steam flows across that spray nozzles and does the final deaeration on the water. As the balance of the steam is transferred through the downpipe and through the scrubbing heater into the first section, it does the preliminary work. Normal atmosphere deaerators are normally the procedure of heating this water is done through a heat exchanger. In other words, pumping from the first section of this deaerator and transferring it through a pump, through a heat exchanger, and the water would be brought up to about approximately 220 degrees and would be flashed down into the deaerating section. As it sprayed into the second section, you would have a certain amount of flash steam. This flash steam would go over. Now you would have a partition in this deaerator, but not completely up. You'd have an open section at the top, and steam would flash into the second section and hope to be used by the spray of the new water coming in. Now what happens there, your control is the unit, the steam or the water is controlled coming from the heat exchanger by a temperature control valve, and it has no correlation with the amount of new makeup water being added to the aerator. So at times you can have a lot of flash steam coming out of here, and other times you'd have a negative pressure. The minute you had a negative pressure, the whole top of the aerator, all the steam would just disappear just like that. And first thing you know, both sections are contaminated. Now, find the separation of a complete baffle in between in here. We have accomplished that this thing is like a pressurized aerator on that side. The only thing is it only has about a half a pound pressure on it. All we want is a positive pressure, and we want that positive pressure at all times. There is no way that air can get into the deaerating section on this unit. In other words, the air can only go up and down in the first section, and this happens at times. In other words, when you're operating a deaerator and they get a surge of cold water in it, you may get a negative pressure in the deaerator, but we only get it in the mixing section. The temperature of the second section or the aerating section will always stay up to a full 212 plus degrees. The 212 plus degrees comes from the purpose that you to get the steam to go into the scrubbing section, you must push the water down, and it's the height of the water in the scrubbing section is what gives us the back pressure in the deaerating section. It always has pressure in it because you have water level in the first section, and the steam has to go through the pipeline, through the heating section, and this creates a back pressure which at a temperature of about 212 degrees, which keeps an absolute constant because of the level of this water. And this is what makes that aerator so successful. And in no time can you get air drawn back into that second section. You may get a little air come back in here occasionally because of the transfer of the new makeup water or condensate coming back that gives you a little surge. And if it does, that cool water coming in there will, just like that, kill all the steam in that section. But it'll pick itself right back up again. Basically, you have no corrosion because I'm keeping that first section up to 210 to 211 degrees, and I'm keeping the other one up to 212 plus. And all our oxygen removal is taken right at the body of the water, so you don't have corrosion. This is the biggest problem you have with all. For example, if you use a condensate receiver and you take the new makeup and you add it to the condensate receiver, and you add your condensate return in there, and you get an average of 180 degree condensate coming back, and then with the new makeup water, you on up with 190 degree water. You make the finest corrosion system that you can have, because all of this new makeup water has got all this oxygen in, and it starts removing throughout the whole body. So you get corrosion on the side sheets of that condensate receiver. And 5 years from now, you got to buy a new condensate receiver. Here, you can go over and you've got the whole package complete, and it's protected as best as it possibly can have. At the first section of this deaerator, we're controlling the temperature in this section at 210 to 211 degrees. So the water, new makeup water that comes in, falls on the surface of that hot water and is immediately brought up to temperature. We say 210 degrees, but you must realize around the heating element of this unit, a good deal of the time, the water temperature is over 212 because the temperature controller is set higher up in the leveling. It must keep that 210 up there, so it is hotter down below. This gives you the effect of getting all the oxygen removed in the center of this section, not around the outside walls, which normally cause corrosion. Now, the deaerating section of this unit is just like a pressurized aerator. It's always under pressure, never get any oxygen, and never going to get any corrosion. So what happens is you get a tremendous amount of steam going across these spray nozzles, and then that steam has to go into the pipe, down pipe, and get into the second section and bring the second section up to temperature. So the second section has the temperature controller in there, and we set that baby right at about 210, and she just sits there and floats. First, it pumps the condensate back at a lower temperature and mixes this condensate with the new makeup water into the first section of this deaerator. It can take in 250 degree condensate, but the flash steam goes into the second section as well as the condensate. The flash steam goes over the top of the spray nozzles and then must transfer into the mixing section. And the condensate itself, of course, drops right into the second section because fully deaerated condensate. Now, this is the advantage of this SprayFlow 2 deaerator because it's completely sealed separate, that we can do this. Because otherwise, if you had an opening, the steam would fly right out of the top of that second section. Since it's sealed off, you can't do it. Pump condensate is pumped into the mixing section of this deaerator, the same as your new makeup water. It comes into the same location and is sprayed through the spray nozzle. If it's gravity flow, that means that the condensate is 005 condensate because it had not been open to air from the time it came from the process. And if this condensate is over 212 degrees, it enters the deaerating section. And there it will flash down to the corresponding pressure we have in that deaerator, which is about 212.5 to 213 degrees. That means that this steam, if we put it in the first section, would flash off. But this way, why that flash steam goes right and is used just like a new steam is being used and goes through the downpipe into the heating section and heats the first section. So you can have a continuous flash steam coming into that unit from traps and other process equipment, and it will heat the water in the first section, but first it must cycle through the second section. The construction of the atmosphere SprayFlow 2 deaerator is it's built in the same manner as a pressurized deaerator. In other words, the material thickness is the same. The welding is as thorough as it is in the pressurized deaerator. It's done through the same procedures, but it isn't. It's an atmosphere deaerator. It does not require inspection. It does not require code, and it can't blow up because it goes up the atmosphere.
Now, there are times when a SprayFlow 2 is not appropriate for the application. Good product, wrong application. And probably the one that you'll run into more than anything else is that the customer has a mindset for a pressurized deaerator, okay? And that's something that sometimes you are effective in being able to turn around, okay? Because in many cases there will be no technical a reason to stay with a pressurized deaerator, but the customer's mindset is, hey, pressurized, and you're really swimming upstream if you continue to do that. The other constraint and the other reason that will go away from a SprayFlow 2 deaerator to a steam flow is if the average feed water temperature is greater than 200 degrees F.
The industrial steam flow deaerator has been manufactured for better than 24 years. The unit was an exceptional unit at the time that we started with it because of the recycling part of the system.
What we have here is a unit that recycles. I call it recycling deaerator, recycle pump. It doesn't recirculate. Recirculate would be within its own vessel. And transfer, you just transfer over and it's gone. It never comes back. This recycles. And what it does, this recycle pump is designed to pump 125 to 130 some odd % of the output. So that this goes, okay, so the water falls in here through the steam phase, adding steam here, sensing the steam pressure. Again, very much like the jet spray, except you notice that it goes in against a stainless steel vent condenser. The gases have to go through the thing to get outside to vent. Again, air and steam. Now the green is the air, the red steam. As the water is sprayed in here, it draws steam here. Pure steam, purest water. These are neat little nozzles. They throw a full cone, 120-degree spray. It completely fills this thing with a fog of fine particulate water. You can imagine the thin film and the turbulence all taking place in this part here for final deaeration. This steam goes over here, scrubs the last traces of oxygen out of it, brings some of that oxygen across here, and goes over here and gets out here, and the oxygen goes out through the tray. The water falls down here. It's modulated from this level here. No level control here because it overflows. You don't need it. You don't transfer with this. It recycles back. You only need one right here. Hold the level about halfway. This runs about 2/3 full. And what happens is, as this pump runs, this level stays higher, and some of the water goes this way. At zero load, nothing coming out of here, 130, 25% of it goes over. All of it. At 100% load, only 25% is recycled. So, obviously, at loads between 0 and 100%, you get less and more of the recycle. This recycled deaerated water mixes intimately with pump returns, which goes through what we call an anti-flash manifold, because when you trap high pressure stuff back to this, it automatically separates the steam from the water noiselessly without causing a flashing. See, what happens here is the change in this temperature, seeing this is a big body of water, nearly the same temperature this is, even if you take a lot of pump stuff to it, you don't shock the system. You don't shock. Maybe you drop from 220 degrees down to 215 degrees if you took a big slug over. Big deal. This will never notice that. But if it went from 227 down to 60 degrees like that, you'd never keep up. This valve would drive you nuts. So the idea is this stable operation. This only sees one flow rate, doesn't see a varying flow rate. It may see a slightly changing temperature, very slow, but it only sees one flow rate. It sees 125% of what could go out of here at maximum flow rate. Again, the water goes here, flows up through here, over it flows into here, mixes with the pump returns, mixes with the trap returns. The steam is utilized here preferentially from the trap stuff into here for heating. This valve here, which we don't show the valve, adds steam as required. This unit here will utilize a lot of high pressure trap stuff. The locking nuts that we talked about adjusting it is right here. You screw them down further, the valve will open up only this far or less. Normally, there's no need to do that. In fact, we've only done that once or twice.
Will those loosen up or?
Yeah, they're double nutted.
They're double nutted.
Yeah, they're double nutted. So that's it. It's got a fits between two flanges. Flange here, gasket. Flange here, gasket. Sometimes we use a T. If we have 100% makeup, we'll just use an elbow because you only get the makeup in here. You get pump returns this way and makeup this way. We usually put the T up here. Take the pump turns this way, water in this way, out here, depending on the flow. Now it takes quite a bit of pressure to open it, but you can imagine there's 3 or 4 square inches, so 1 pound is 3 pounds of force. It's really not that bad. These are the little constantly recirculating, look like pigtails. Cute, aren't they? Do a beautiful job. This is a 3/4, this is a 1/2 inch. They go down to 1/4 and 3/8. And I want these back because they belong to a job, but I'll pass these around too. This is the nozzle we use for recycle. These are metered to a point where they're almost dead accurate. In other words, our recycle pump pressure is around 25 pounds. And we know at 25 pounds exactly how much one of these will pass. We've tested them, and they're right on. So we know that if we put, say this is good, these are good for a lot of, this could be good for maybe 50 gallon a minute, actually. So if you had a recycle rate of 200 gallon a minute required, you put 4 of those in, you got 200 gallon a minute.
Let's suppose that you have a replacement deaerator application, and there's an existing surge tank. Okay, now you don't need that dual section that you get in the steam flow. So why pay additional money? Why should the customer pay additional money for the steam flow if he already has a surge tank? Okay, and if he has a surge tank there, then it's appropriate to quote a jet spray. If the steam flow deaerator is basically out of his budget, that's another reason for going in with a jet spray.
We're going to talk about pressurized deaerators. This is kind of our bread and butter deaerator, the one that competes with all your people like Cleaver Brooks, BFS, York Shipley, etc. It's called a jet spray deaerator. Now, for those of you that don't know how a jet spray works, I think we need to talk about it a lot, and I'll tell you why, because it has some disadvantages too, and I need you to listen to that. We pray on them, we talk about them in our newsletter, I talk about them on all our things, we even put it on our drawings. Pump returns only, you know, no trap returns, we still get people putting trap returns in the pump return opening. And you cannot do that, but that's another story for a minute. But anyway, what we do is take up and pumped returns. See this word, pumped returns? In here. They're pumped in through a nozzle that has an adjustable orifice in it. I've got a drawing on it. In fact, maybe I'll show that to you real fast so you'll know what I'm talking about. Then I'll go back to this one. But this is our spring-loaded. The reason we use a spring-loaded nozzle is because the more water there is, the more water, the wider the spray, but it doesn't fall and it comes under force. And it's set to go at a 45-degree angle, and it's got a spring here, and you got a little stop on it here, so that the thing can only go so far. Now, if you have a deal where they're pumping too much cold water in here due to a big pump out in the plant there, and they won't shorten the stroke or restrict it, you can do it yourself here by pulling it out and just pinching down this so you don't open it up quite as far, and let the pump work a little longer out in the plant. Because usually your city water has 40 pounds pressure, so you got plenty push over there, but it does have what they call an anti-flash feature in it that lets you adjust the opening. That's our nozzle, and I'll go back to this. Now that is this guy right here. I guess I could have shown it here. Anyway, I got it backwards. Sorry. You notice this is a hollow cone, so there's no water down the middle, and we put a vent pipe right in the center. And we bleed off gases all the time. The green arrow is your air, your blue or purple, came out kind of purple in this, is your water, and the red is the steam. We have to get rid of some of the steam to get rid of some of the air because it's mixed. And it has to go through here. Now, since this is cold water, most of your steam is recondensed and formed down here. The air, of course, will not reabsorb. It goes on through. Because this, by the time it gets this far, believe it or not, if you could put an infinite number of thermocouples in that spray, starting from here to the time it hit the tray, you'd find that by the time it got in this area here, it'd be up to almost corresponding temperature. That's how fast steam wants to go into water. It's totally incredible. So cold water has a tremendous attraction for steam, and if you don't believe that, where do you think water hammer comes from? You never get in trouble putting cold water into a steam phase like we're doing here, but try to put steam into cold water and you get one hellacious hammer. And that's how you break pipelines and so forth, steam going back into the water. So the steam goes through here, grabs into this water, and I'm going to tell you, like I said, infinite number of thermocouple from here to here. You'd see that by the time the water got in this area here, it was probably up to corresponding temperature almost. And by the time it gets down to here, definitely. It has to be, because you only have boom, 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 2 seconds, best, to get rid of 2,000 times the oxygen. You're taking it down from 12 to 20 parts per million. They can go as high as 20 parts per million in highly aerated sources, down to 7 parts per billion. Because the time it hits the water level down here, you can't deaerate anymore. You're through. If it isn't 7 parts per billion there, it will never be 7 parts per billion in this deaerator. Well, so as you can see, the water goes down. There's a catching pan that catches all the water, and it's directed down through a sleeve. And this is a stainless pipe going down here, and it hits this, we call it a flapper, steam flapper, and the steam pressure, of course the steam's coming in trying to get over here. So it's open, and it's proportional to how much cold water you're putting in here, because it responds immediately. Again, I gotta tell you, pumped returned. We do have an opening over here, and it says for high pressure drips. That means what it says. For maybe 10–15% of the returns to be trapped from overhead drips and things like that in the boiler room. It does not mean you can run 50% trapped returns back to this guy here. None of these types of deaerators will work with that kind of abuse. They're not designed for it. And you need to be thinking about a different kind of deaerator. And Mike, you look like you want to say something.
What's the quality of the condensate coming back to the deaerator?
Oh, this condensate pumped?
No, the drip.
Oh, yeah, a drip. Hopefully it's zero, you know, because it's come from the boiler and it's condensed steam. And if you're doing a good job here, the trapped returns are usually down to 7 or lower, you know, 0, because what they do in the boiler, they treat the water chemically to reduce it from 7 parts per billion down to 0. In fact, any of you that know anything about water treatment know that the sulfite is added sometimes to the deaerator, and we allow sulfite to be added to the deaerator, but we don't like to add any phosphates or something like that. They tend to plug the lines, the pumps, and all those sorts of good things, but sulfite's okay if they want to do it there. But what they do is take this 7 parts per billion and reduce it to 0, because they hold an overage of sulfite of already between 20 and 40 parts per million. So the steam that goes out is literally 0. So theoretically, if it's kept under pressure and there's no way the oxygen can get to it, like Mike says, it comes back here at 0. So there's no harm done. You do not dilute the quality of this unit by trapping back from the overhead. But remember, you get over 10, 15 pounds. If you have a high return situation, talk to us. There's ways you can handle it in this kind of a deaerator, but it has to be, we have to know it in advance. It can be done. We have cases where we have flashing returns taking place, but we have to make adjustments for it. We have to fix the nozzle, for instance. We have to do all sorts of things, but it can be done. Rather do it another way. That's a unit that we sold to Buffalo. It's an overhead, what we call a piggyback, deaerator on top, condensate system on the bottom, transfer pumps, not recycle pumps, not recirculating pumps, but transfer. Takes from this tank here and transfers up to here. Obviously it wasn't shipped in one piece, but it was shipped in 2 pieces and put together on the job. We can build a jet spray vertically in almost any size you want, if they want it vertically. Saves a little room. Gets pretty unwieldy when they get pretty tall, but yeah, we build them up to 1,000. In fact, I got a picture one I'll show you here in a minute. And here's I ran a overhead on it. One thing we do on this, so you got to watch yourself a little bit, because some of the things that are standard on our jet spray are not standard on this. To keep the price down, for instance, the safety, 3-valve bypass is an optional item. Now, the reason we did this was meant to directly compete with Cleaver-Brooks Model 7. And we did the same thing they did. We made them, they add on the other things, they do too. High water alarm is optional, overflow trap is optional, 3-valve bypass, the control panel is optional.
And the fourth and last is unless the customer has a mindset or a specification preference for a tray type or pack type deaerator. And if he does, go ahead and quote it. Keep in mind that you can still quote a steam flow as an alternate, and price-wise, it's going to look real good to him. The tray and pack column deaerators rounds out Industrial Steam's line of pressurized deaerators. And what we want to do is talk about some of the significant differences between our deaerators and the competition. Some of the most significant differences between our line of tray and pack deaerators and the competition is configuration and materials of construction. Cochrane and a couple of the other competitors utilize a co-current downflow configuration for their spray type units. Industrial Steam and some of the other companies operate countercurrent or counterflow with the water coming in the top of the deaerating section and steam in the bottom of the deaerating section. We've elected to go to the countercurrent flow because it's a more effective and more efficient way of deaeration. And furthermore, Cochrane, among others, have had a significant amount of problems with the deaerating section failing after 5 to 10 years of operations. One of the reasons why those units fail is because in a co-current flow situation, they have continuous absorption and desorption of air, and they set up an internal recycle of air, and that results in high oxygen concentration and corrosion of that tray section. We're countercurrent flow, and that simply doesn't happen. One of the other things that you'll find in some of the competition is adherence to some very, very old specifications and the use of 400 series stainless steel. That was once thought to be okay, but probably the best use you can make of 400 series stainless steel is for cookware. Beyond that, it isn't worth much at all. The problem that the stainless steels have to deal with in deaeration is they have to deal with the chlorides that are present in the water. And 400 series is subject to severe stress corrosion. Next better is 304 stainless steel, which is our standard. And the best thing you could put in there is 316 stainless, which is suitable for high chlorides and even brine service. We'd like to recommend that you specify 316 wherever you can, but keep in mind some customers aren't going to be willing to spend the extra amount of money to go to 316 stainless steel. In terms of size and configuration, we can make tray type deaerators probably up through 750,000 to 900,000 pounds per hour. The truth is that the size is not limited by our manufacturing capability, it's limited by what we can ship. To give you an example of some of the things we have made in our shop, we've built tanks in our shop 10 feet in diameter, 64 feet long. And if you were to make that equivalent to a deaerator, that'd be over 1.25 million pounds per hour. But the truth is, that's too big to ship. So basically what we're saying, we're in the 750,000 to 1 million pound per hour maximum range. What we'll catalog for you will be in the 300,000 to 600,000 pounds per hour. We make the tray and pack column units in two different configurations. In the first configuration, the tray section is welded to the receiver. When the unit gets over 12 feet in height, which is basically the limit that we can ship, here again, we're restricted by shipping. When we reach that point, we have to break the deaerator in two, and we fabricate the tray section and the receiver section separately and flange them together. We use 304 stainless steel as standard for the tray. Our tray housing is also 304 stainless steel, and the spray nozzle is 304 stainless steel. If you find any old specifications that customers are still using that require 420 stainless steel, we'll build the trays and the tray housing out of the 400 series stainless steel. We don't want to do it. It's not a good application, it's not a good recommendation, and we'll do the 304 stainless for them at the same price. Finally, we want to talk about deaerator sizing for both pack column and tray type units. The sizing is relatively straightforward and easy when it comes to sizing spray type deaerators. You size the receiver for 10-minute storage, and the only real difference from deaerator to deaerator is the size of the steam valve and the water makeup valve. So if you have a case for 20% fresh makeup or 80% makeup, you really don't change the receiver size. All you change is the steam and water valve size, and it has a minor impact on price. And this is not so with tray units. Okay, tray units are sized receiver first and tray section second. Well, the receiver is sized the same way that a spray unit is sized. It's sized for 10-minute storage capacity. The tray unit receiver is sized for 10 minutes storage. In sizing the tray section, it's sized for average makeup temperature. And if you have 20% returns, you have relatively cold makeup, and you end up with an extremely large tray section. The size of the tray section is a function of the amount of steam that we have to use to heat all that water. So if you only have a little bit of fresh makeup, you don't have to heat very much water. If you have a lot of fresh makeup, you have a lot of water to heat. And what it means is that the diameter of the tray section can be almost twice as large in one particular case, and a corresponding increase in cost. So it has a big impact. We're extremely concerned about makeup temperature on a tray unit because it has such a big impact on price. We have them all. Okay, we do. We have 5 deaerators. Jim and I have already covered the 5. You know, we have 4 pressurized deaerators and an atmospheric deaerator. In the pressurized, we have 2 sprays, and then we have a tray and a pack column. So we have the world covered.